Hi dear children, welcome to today's class. Today we are going to discuss exercise 6.5. First question. Find the maximum and minimum values if any of the following functions given by. First one, f of x is equal to 2x minus 1 all square plus 3. So the f dash of x is equal to, we need to take the derivative of given f of x. That f dash of x we will get it as 2 into 2x minus 1 into d by dx of 2x minus 1 plus the derivative of 3 is 0. That is 2 into 2x minus 1 into the derivative of 2x is 2 and the derivative of minus 1 is 0. This is equal to 4 into 2x minus 1. So the derivative of f of x is 4 into 2x minus 1. Now we will take the derivative once again, that is f double dash of x, second order derivative of f of x, that is equal to f double dash of x means we need to take the derivative of f dash of x. That is equal to 4 is constant and the derivative of 2x is 2 and the derivative of minus 1 is 0. So this we will get it as 8. Now actually to get the point of maximum and the point of minimum, we are going to use the second derivative test. We are going to use the second derivative test. So we got this f dash of x and f double dash of x. Next we will equate this f dash of x into 0 to get the critical points. That is 4 into 2x minus 1 is equal to 0. 2x minus 1 is equal to 0. 2x is equal to 1. X is equal to 1 by 2. Here we have only one critical point. That is x is equal to 1 by 2. Now the next step is we need to find out the sign of our f dash of x at x is equal to 1 by 2. That is f double dash of 1 by 2. We need to find out the sign of f double dash of x. We need to find out the sign of f double dash of x at x is equal to 1 by 2. That is f double dash of 1 by 2 is equal to, we know that this f double dash of x is 8. There is no term which contains x in this f double dash of x. Then therefore this f double dash of 1 by 2, that is also 8 and it is greater than 0. So by using second derivative test, since the sign of f double dash is greater than 0 at x is equal to 1 by 2, we have the point of local minima at x is equal to 1 by 2. This x is equal to 1 by 2, that is the point of local minima. Okay, that is the point of local minima, and this minimum value, that is f of 1 by 2, minimum value, that is f of 1 by 2, that is 2 into, just put x is equal to 1 by 2 in f of x, that is 2 into 1 by 2 minus 1 all square plus 3. 2 into 1 by 2 minus 1 all square plus 3, that is equal to 3. So what is our conclusion? The conclusion is the point of local minima is x is equal to 1 by 2 and that local minimum value of our function f is 3. Now the second sub question, f of x is equal to 9x square plus 12x plus 2. Take f dash of x, that is 18x plus 12, and f double dash of x we will get 18. Now to get the critical point we will equate f dash of x into 0. Thus implies 18x plus 12 is equal to 0, implies x is equal to minus 12 by 18. X is equal to minus 12 by 18, that is equal to minus 2 by 3. Now we will check the sign of f double dash at x is equal to minus 2 by 3. Here we don't have any term which contains x in our f double dash of x. So this f double dash of minus 2 by 3, that is 18 and it is greater than 0. And if it is greater than 0, this x is equal to minus 2 by 3. That is the point of local minima. This is a point of local minima. and that local minimum value, that is f of minus 2 by 3 is equal to 9 into minus 2 by 3 all square plus 12 into minus 2 by 3 plus 2, and this is equal to 2 we will get. Therefore, the local minimum value of our function f at x is equal to minus 2 by 3 is 2. Now I am going to do the second question. Second question also we need to find the maximum and the minimum values if any of the following functions given below. If any of the following functions given below. Second one, first question. F of x is equal to mod x plus 2 minus 1. F of x is equal to mod x plus 2 minus 1. Here we have this modulus, so we can't directly differentiate it. What we are going to do is, we know that the modulus of any value, okay, that is always greater than or equal to 0. Modulus of any value that is always greater than or equal to 0. Therefore, this mod x plus 2 is also greater than or equal to 0 for all x belongs to our real number set. For all x belongs to our real number set. Now, I am going to do one operation and this inequality, that is on both sides I am going to do minus 1. Okay, so mod of x plus 2 minus 1 greater than or equal to minus 1 we will get. Okay, just do this operation on both sides. What is this actually? This is our f of x. So we got f of x is greater than or equal to minus 1. Always f of x is greater than or equal to minus 1 for all x belongs to our real number set. For all x belongs to our real number set. Therefore, the minimum, okay, or the local minimum value of our f of x is minus 1. At when we will get this minus 1? Okay, just look at this function. If this part becomes 0, then we will get f of x is equal to minus 1. When this part becomes 0, we need to get 0 inside this modulus. Okay, how we will get 0 inside this modulus? This x become minus 2. Okay, that if x is equal to minus 2, then f of x is, what is our f of x? Minus 2 plus 2 minus 1. That is 0 minus 1 is equal to minus 1. Therefore, f of x has a minimum value minus 1 at x is equal to 2. At x is equal to minus 2. Okay, but we don't know about the maximum value. Now, the second sub question. In second one also we have this modulus. G of x is equal to minus of mod x plus 1 plus 3. Minus of mod x plus 1 plus 3. Same method. We know that this x plus 1 is always greater than or equal to 0. X plus 1 is always greater than or equal to 0 for all x belongs to real number set. Now just I need to get minus here. So just multiply this inequality throughout by negative. Then minus x plus 1. And then if you multiply it with a negative, the 0, that 0. There is no change for 0. But here we have the change for the sign. This is become less than or equal to. If you multiply your inequality with a negative, that sign will change. Okay. So we have minus of x plus 1 is less than or equal to 0. What we want to get here, we need to get minus of x mod x plus 1 plus 3 we need to get. So just add plus 3 on both sides. So minus of x plus 1 plus 3 less than or equal to 0 plus 3 is 3. This is our g of x. That is our g of x. And what we got is g of x is less than or equal to 3 for all x belongs to R. That means the maximum value of g of x is 3. Maximum value of g of x is 3. And if you want to get this g of x 3, then this term that should be equal to 0. Okay, there's term minus of mod x plus 1 that should be is equal to 0. When it has become 0, this the term which lies inside the modulus equal to 0. Okay, so that we will get at x is equal to minus 1. If x is equal to minus 1, g of minus 1 is equal to minus of modulus of minus 1 plus 1 plus 3. Minus 1 plus 1, that is 0, and this we will get it as 3. Okay, so the conclusion, g of x has maximum value 3 at x is equal to minus 1. But we don't know anything about the minimum value of this g of x. Third one, h of x is equal to sine 2x plus 5. h of x is equal to sine 2x plus 5. We know that the maximum value of a sine function, sine is always less than or equal to 1. Minus 1 less than or equal to sine less than or equal to 1. The maximum and the minimum value of sine and cos functions is minus 1 and 1. Okay. So the sine 2x is also lies in between minus 1 and 1. Now I need to get the sine 2x plus 5. Then only I can write h of x. So I need to get plus 5 in the middle term. So I am going to add plus 5 throughout this inequality. So minus 1 plus 5 less than or equal to sine 2x plus 5 less than or equal to 1 plus 5. What is this? 4 less than or equal to sine 2x plus 5 less than or equal to 6. 4 less than or equal to sine 2x plus 5, that is our h of x, less than or equal to 6. What we got here? The minimum value of our function, that is 4, and the maximum value of our function is 6. Okay. Now, fourth question. F of x is equal to modulus of sine 4x plus 3. F of x is equal to modulus of sine 4x plus 3. Okay. Same method. Sine 4x is always lies in between minus 1 and 1. Sine 4x, the sine is always lies in between minus 1 and 1. Therefore, the sine 4x is also lies in between minus 1 and 1. I need to get sine 4x plus 3. So, I will add plus 3 throughout this inequality. So, minus 1 plus 3 less than or equal to sine 4x plus 3 less than or equal to 1 plus 3 we will get. This is 2 less than or equal to sine 4x plus 3 less than or equal to 4. 2 less than or equal to sine 4x plus 3 that lies in between 2 and 4, and this 2 and 4 that is positive. So if you took modulus throughout, what you will get? Mod 2 less than or equal to modulus of sine 4x plus 3 less than or equal to mod 4. Mod 2 is 2 itself. Modulus of sine 4x plus 3 less than or equal to mod 4 is 4 itself. This is our f of x, and we got the minimum value of f of x is 2 and the maximum value of f of x is 4.